Hello. In the previous two videos, we have taken care into account two very basic methods which are used historically to calculate the heating and cooling building loads. And those were the basic degree day method, which is seen here, and the modified degree day method, which was MDD. In this, we are going to make a little modification to modify degree days, and we are going to have the new and the last one, which is the variable degree day method. And this is the most advanced but still not used because of the disadvantages it has in the industry. So it is the variable based degree day method. Let's explicitly mention it as base. So variable based degree day method. So the formula it has is very much similar to what we had previously. My QH, which is the building heating load, is given by 24 into UA into number of degree days. Now let's understand each of these factors and how this variable based degree day method is a better version of the previous two, modified degree day and the basic degree day method. So UA total takes into account the windows, walls, roof and infiltration. And I hope you remember that how do we calculate the UA values for each of these factors. Specifically, the UA infiltration has a different methodology of using rho VCP. And I've explained this in the load calculation video explicitly and in much detail. I'll also solve a question on it. And the degree day, let's just mention it here, is Ti minus T average. But this T average is the balance temperature now. And the balance temperature is now Ti minus Q gain upon the UA total. So this variable based degree day method explicitly takes into account the Q gain in the building. So these are the building gains, heat gain in the building. So earlier the H value which we were using in the modified degree day method and the basic degree day method, that is the H value over here, that's the heat gain or heat loss from the building. And the T balance takes into account the heat gain of the building and UA. So we'll be able to have a balanced temperature which can change based on the Q gain or the building specifications. The dimensions can change, or the building materials, if they are changed, my T balance will change, and hence we are going to have a better estimate of our building. Earlier the balance temperature was a constant value of 65. Now this will give us a better estimate. So some of the disadvantages of this is it takes into account the variable varying Q gain, and again the T balance is not a constant value. And the second is we still need very less data. We just need the Q gain, which we can measure very easily, and the U values, which are the building material specifications and the dimensions, and we can provide a very reasonable estimate of our average heating or cooling load over the year. But it is still not taking into account explicitly the hour to hour or day to day variations in our solar or internal gains. So this is still the average temperature over the year. That's the average Q gain over the year. Hence, if we want to see what are the heating requirements or what is the balance temperature in our January month, it would definitely be different than July. But since we are taking into account the average value, still we are not getting a very accurate estimate. But this is an annual estimate for our heating or cooling requirements. And also the internal temperature which we are using is only one of the parameter in hand, base temperature, and still the balance temperature, as I said, remains constant for temperature for January and July month. But the Q gain, which are dependent on the solar gains and the internal gains, will keep on changing based on the months. In summer, we'll have more Q gain because of the solar component, a higher value of the solar component, while in winter season the Q gain will be reduced. So the balance temperature will change, but this is not taken into account over here. This will be taken into account into the fourth method, or the most updated method, which is the bin method, which we'll discuss in a short while in the upcoming videos. And one of the other disadvantage of this method is we need building specific data of the building materials which are used and some of the dimensions of the building, right? Let's look at one of the example of this method, because this method is somewhere still used in the industry somewhere. So we are just going to have a very simple example. We have, I hope this is clearly visible. Yeah. We want to have an estimate of QH, which is given by 24 into UA total into degree days. For the building, my T UA total is given by 500 BTU per hour degree Fahrenheit. My Q gain for the building is given as 5000 BTU per hour. My internal temperature which I want is 72 degree Fahrenheit. So based on these three values, I can calculate the value of balance temperature as this: Ti minus Q gain upon UA total, which will give me Qi, which is Ti, which is 72, minus Q gain, which is 5000, which is UA, which is 500. So this is 72 minus 10. So my T balance is 62 degree Fahrenheit. So now it is not 65 as it was a constant value in the previous one. Now it is 62 degrees Celsius. And you can take any values of degree days. That depends on the weather, because what the degree day calculation would be for each of the days of the year. For the first 1, 2, 1, 3, we'll have the outdoor temperature, and based on the balance temperature we'll be able to figure out the value of degree days, and then we add up all the degree days. We sum up all the degree days, and that's the total value of degree days, and that's how we get the QH value, total QH value. So I hope you have got the very basic understanding of variable based degree day method, and still we are not going to solve questions on this because they are not used in industry extensively. The bin method, which we'll be covering in upcoming videos, is definitely extensively used in industry right now, and that's where we'll be having our most focused on. Thank you.